Imagine standing on the surface of a distant planet, your boots crunching against alien soil, a sky full of unfamiliar stars stretching above you. Or picture yourself floating inside a gleaming space station, gazing down at Earth as swirling. Blue marble suspended in the infinite blackness of space. The idea of living beyond our planet has captured human imagination for centuries. From ancient myths of gods in the heavens to modern science fiction epics. But today, this dream is no longer just a story. Scientists, engineers, and dreamers are working together to answer a profound question. Can we live in space? Let's explore this question together, diving into the challenges, the possibilities, the incredible steps humanity is taking to make life beyond Earth a reality. Space is vast, mysterious, and unforgiving. It's a place where the rules of life as we know them on Earth don't apply. There's no air to breathe, no water to drink, and no ground to grow food. The temperature can swing from blistering heat to bone-chilling cold in moments, and radiation from the sun and distant stars bombards everything unprotected. Despite these challenges, humans have already taken their first steps into space. Astronauts have lived on the International Space Station for months at a time, and we've sent probes to Mars, the Moon, and beyond. While living in space truly, making it a home requires far more than temporary visits. It means building sustainable habitats, finding ways to grow food, managing resources, protecting our bodies and minds in an environment that's inherently hostile to human life. Can we overcome these obstacles? Let's start by looking at why we even want to live in space. The drive to explore space comes from a mix of curiosity, necessity, and ambition. Humans have always looked to the stars, wondering what's out there. But today, there are practical reasons too. Earth's resources are finite, and our population continues to grow. Some scientists and thinkers, like Elon Musk, argue that becoming multi-planetary species living on other planets like Mars could protect humanity from global catastrophes, like asteroid impacts or climate disasters. Others see space as a frontier for scientific discovery, offering clues about the origins of life and the universe. And then there's the economic angle. Mining asteroids for rare minerals or building space-based industries could transform our economy. But to achieve any of this, we need to solve some big problems. Let's break them down one by one, starting with the most basic requirement for life. Air on Earth, we take oxygen for granted. It's in every breath we take. In space, there's no such luxury. The vacuum of space means no atmosphere, no air, and no pressure to keep our bodies functioning normally. Without a spacesuit or a sealed habitat, a human would lose consciousness in seconds and die shortly after. So, how do we get air in space? On the International Space Station, or ISS, astronauts rely on complex life support systems. Recycle air by removing carbon dioxide, the stuff we exhale, and adding fresh oxygen generated through a process called electrolysis, which splits water molecules into hydrogen and oxygen. It's a remarkable system, but it's not perfect. The ISS depends on regular resupply missions from Earth to bring water and backup oxygen. If we're going to live on the Moon or Mars, we can't rely on constant deliveries from Earth. It's too far and too expensive. So, scientists are exploring ways to produce oxygen in space. On Mars, for example, the atmosphere is thin and mostly carbon dioxide, but it's not useless. NASA's Perseverance rover carries an experiment called MOXIE, which stands for Mars Oxygen Insight to Resource Utilization Experiment. MOXIE takes carbon dioxide from the Martian air and converts it into oxygen using a process called solid oxide electrolysis. In 2021, MOXIE produced about 5 grams of oxygen per hour, enough for a person to breathe for about 10 minutes. It's a small start, but it proves we can make oxygen on another planet. Imagine scaling that up to support a whole colony. It's not science fiction anymore, it's science fact. But air is just the beginning. What about water? Water is essential for drinking, growing food, and even producing oxygen and fuel. On Earth, water covers about 70% of the planet's surface. In space, it's much harder to come by. The ISS recycles nearly 90% of its water, including sweat and even urine, through advanced filtration systems. Sounds gross, but the water astronauts drink is purer than most tap water on Earth. For long-term space living, though, we need to find water sources off-planet. The good news is that Water exists in space, often in the form of ice. Scientists have found ice in the permanently shadowed craters of the Moon's poles and beneath the surface of Mars. NASA's Artemis program, which aims to return humans to the Moon by the late 2020s, plans to mine this lunar ice for water, oxygen, and even hydrogen to use as rocket fuel. On Mars, rovers have detected signs of ancient rivers and lakes, suggesting that water ice is still present underground. Extracting and purifying this ice will be a challenge, but it's a critical step toward sustainable space habitats. Now, let's talk about food. You can't live in space without something to eat. Astronauts can't survive on freeze-dried packets forever. Growing food in space is one of the biggest hurdles to long-term living. On the ISS, astronauts have experimented with growing plants like lettuce and radishes in small hydroponic systems, which use water and nutrients instead of soil. These experiments, like NASA's Veggie program, show that plants can grow in microgravity, but it's not easy. Plants need light, water, and nutrients, and space stations don't have much room or resources to spare. On Mars or the Moon, the challenge is even greater. The lunar surface has no atmosphere to filter sunlight, and Martian soil contains toxic chemicals called perchlorates. Scientists are working on ways to clean Martian soil or grow plants in controlled environments, like greenhouses. For example, experiments in the Netherlands have simulated Martian and lunar soil to grow crops like tomatoes and potatoes. The results are promising, but scaling up to feed a colony will take time and innovation. What about protecting ourselves from the harsh environment of space? Space is a dangerous place. Beyond the lack of air, water, and food, there's the constant threat of radiation. On Earth, our planet's magnetic field and atmosphere shield us from harmful cosmic rays and solar radiation. In space, there's no such protection. Astronauts on the ISS are partially shielded by Earth's magnetic field, but they still face higher radiation levels than we do on the ground. A trip to Mars, which could take 6 months or more, would expose astronauts to even more radiation, enough to increase their risk of cancer over time. To live in space, we need habitats that can block radiation. One idea is to build underground shelters on the Moon or Mars, using the natural soil or regolith as a shield. Another is to use advanced materials, like water-filled walls or lightweight composites, to absorb radiation. NASA and private companies like SpaceX are designing habitats with these protections in mind. But we're still years away from fully safe, long-term solutions. And then there's gravity, or the lack of it. Gravity shapes life on Earth in ways we don't always notice. It helps our bones stay strong, our muscles work properly, and our blood flow normally. In space, the low gravity or microgravity causes all sorts of problems. Astronauts on the ISS lose bone density and muscle mass, even with regular exercise. Their hearts don't have to work as hard to pump blood, which can lead to cardiovascular issues. Over months or years, these effects could make it hard for humans to live in space without serious health problems. Okay? On Mars, gravity is about 38% of Earth's, which might be enough to reduce some of these effects, but we don't know for sure. Scientists are studying how to simulate gravity in space, perhaps by building rotating habitats that create artificial gravity through centrifugal force. It's a concept straight out of science fiction, but engineers are seriously exploring it. Health isn't just physical, though. Living in space can take a toll on the mind. Imagine being stuck in a small, crowded space station for months with no fresh air, no natural scenery, and the same few people around you every day. It's isolating, stressful, and mentally draining. Astronauts are trained to handle these conditions, but even they face challenges like depression or anxiety during long missions. To live in space, we'll need to design habitats that support mental health. That means creating spaces with natural light, greenery, and room for privacy. Virtual reality could help, letting people escape to virtual forests or beaches. Social dynamics will also matter. Colonies will need diverse teams with strong communication skills to avoid conflicts. NASA's HI-SEAS program in Hawaii has simulated Mars missions to study how people cope with isolation. And the results show that teamwork and mental resilience are just as important as technology. So, we've covered air, water, food, radiation, gravity, and mental health. But what about energy? Everything in a space habitat, lights, computers, life support systems, needs power. On Earth, we rely on fossil fuels, nuclear plants, and renewable energy like solar and wind. In space, solar power is the most practical option. The sun shines constantly in space, with no clouds or atmosphere to block it. The ISS uses huge solar panels to generate electricity, and future lunar or Martian bases will likely do the same. But there are challenges. Solar panels need to be lightweight and durable to survive launch and space conditions. On Mars, dust storms can cover panels and reduce their efficiency, as NASA's rovers have shown. Batteries are also critical for storing energy during long nights, like the 2-week lunar night. Some scientists are exploring nuclear power for space using small reactors to provide steady energy. These systems are still in development, but they could be a game changer for long-term colonies. Now, let's think about building the habitats themselves. A space habitat needs to be strong, airtight, and able to withstand extreme conditions. On the ISS, habitats are made of lightweight metals, like aluminum, designed to survive micrometeorite impacts. But for the Moon or Mars, we might use local materials to save on launch costs. On the Moon, regolith can be turned into concrete-like materials, or even 3D printed into structures. ESA. The European Space Agency has tested 3D printing lunar soil to build habitats, and the results are promising. On Mars, similar techniques could use local soil or even lava tubes, natural underground tunnels formed by ancient volcanic activities. Ready-made shelters? Private companies are getting involved too. Bigelow Aerospace has developed inflatable habitats that are lightweight and expandable, perfect for space missions. These ideas are exciting, but they're still in the testing phase. What about getting to space in the first place? Space travel is expensive and complex. Launching a single kilogram of material into orbit can cost thousands of dollars. To make space living affordable, we need cheaper rockets and reusable spacecraft. SpaceX has led the way here, with its Falcon 9 and Starship rockets designed to be fully reusable. Starship, which is still in development as of 2025, could carry dozens of people and tons of cargo to the Moon or Mars at a fraction of the cost of traditional rockets. But cost isn't the only issue. Space travel is risky. Rockets can fail, and long journeys expose astronauts to radiation and microgravity. We'll need reliable, safe spacecraft to make space living a reality. Once we're there, how do we govern a space colony? Living in space isn't just about technology, it's about people. A Martian colony, for example, would need rules, laws, and a way to make decisions. Would it be a democracy? A scientific outpost run by a space agency? A private company's settlement? These questions are already being debated. The Outer Space Treaty of 1967 says that space belongs to all humanity. It's not any one nation, but it's vague on details like property rights or resource mining. It's more countries and companies like China, India, Blue Origin, and SpaceX get involved in space. We'll need clear agreements to avoid conflicts. Some experts suggest that space colonies might develop their own cultures and systems, much like early human settlements on Earth. It's a fascinating possibility, but it raises ethical questions too. Who gets to live in space? How do we ensure fairness and access? Let's zoom out and look at the bigger picture. So far, we've talked about the technical and social challenges of living in space. But why does this matter? Beyond survival and exploration, living in space could change who we are as a species. It would push the boundaries of human ingenuity, forcing us to solve problems we've never faced before. It could unite us as nations and companies work together toward a common goal. Or it could divide us if competition for resources or territory spills into space. The history of space exploration gives us hope. The Apollo program put humans on the Moon in 1969, a feat that seemed impossible just a decade earlier. Yes, a collaboration between the United States, Russia, Europe, Japan, and others has been a symbol of global cooperation since 1998. If we can achieve these things, maybe we can build homes in space too. Let's look at some real-world examples of progress. NASA's Artemis program aims to establish a permanent human presence on the Moon by the end of the 2020s. The plan includes a lunar base camp and a small space station called Gateway orbiting the Moon. China's Tiangong space station, completed in 2022, shows that other nations are serious about space living too. On the private side, SpaceX's Starship could make regular trips to Mars possible within the next decade. These projects aren't just dreams, they're backed by billions of dollars and thousands of scientists and engineers. But there, not without critics. Some argue that we should focus on fixing problems on Earth, like climate change or poverty, before spending billions on space. Others worry about the environmental impact of rocket launches or the risk of contaminating other planets with Earth microbes. These are valid concerns, and they remind us that space exploration must be responsible and inclusive. What does the future hold? We solve the challenges of air, water, food, radiation, gravity, and more. We could see small space colonies within our lifetime. Lunar base could be a stepping stone to Mars, and Mars could lead to even more ambitious destinations, like the moons of Jupiter or Saturn. But living in space won't be like living on Earth. It will be hard, dangerous, and expensive. It will require sacrifice and innovation. Yet, the rewards could be immense. It's not just in resources or scientific knowledge, but in what it means for humanity. To live in space would prove that we can overcome any challenge, that our curiosity, resilience, know no bounds. Let's wrap this up. Can we live in space? The answer is a cautious but hopeful yes. We have the technology to take the first steps: oxygen generators, water recyclers, plant growth systems, and reusable rockets. We have the knowledge to tackle radiation, gravity, and mental health challenges, even if we're still learning. And we have the ambition, from governments to private companies to dreamers around the world. The road ahead is long, and there will be setbacks. But every step we take, every rover on Mars, every experiment on the ISS, every new idea brings us closer to a future where humans can call space home. So, the next time you look up at the stars, imagine not just visiting, but staying, living, thriving. Because if we dare to dream it, we can make it real.